And not only that, it has extraordinary mechanical properties, right? It can be as stiff as diamond, right? And stronger than steel. Okay? Imagine that carbon. What is the mass, atomic mass of carbon compared to steel, iron? What is the atomic number of iron? 56. What is carbon? 12. So it's about 5 times lighter. And if that is stronger than steel, then 5 times stronger than steel, would you prefer to use steel or use carbon to build your vehicle, airplane, to construct your building? You would like to use carbon, but not ordinary carbon. You don't use graphite to build your building. You don't use diamond to build your building, right? So you might consider to use carbon nanotubes. How does it work? Okay, I believe that those at this side will have this, right? Okay. Now, if you have this graphene sheet, okay, you can see that if you try to join this edge here on your left-hand side to the edge on your right-hand side, if you join them, okay, those not holding the sheet, you can look at your friend's side. If you join them, can you see that you can form a seamless, no defect, seamless, they join perfectly, just like a gate. Okay, seamless. You form a seamless tube. Okay, once you do that, you can see that the mark down here, it looks like a zigzag shape, right? So this is what we call zigzag carbon nanotube. Okay, and for those group over here, okay, you see something like this, right? So actually, the first group can do the same. You just have to rotate your sheet 90 degrees, right? You can see that if you join this zigzag edge to this side, you will form seamless cylinder. Roll it to the cylinder, roll it to a cylinder, okay? And look at the side here, then you can join it to the other side. Can you do that? Any questions? Okay, now look at the mark they are written down here. Does it look like a chair when you look at it from the side? Okay, we call this armchair carbon nanotubes. Okay? And it depends. If you have an armchair carbon nanotubes, okay, these are metallic. It will just conduct electrons like graphite. For those who are having zigzag nanotubes, you have the chances, 2/3 of the chances that they are semiconductor. Right? And if you don't believe me, you can throw this shade, right? Not just in this direction or this direction, in any direction between 0 to 3 or 30 degrees. And of course, 30 degrees symmetry will be 60 and 90. So in any direction that you fold, you'll find the possibility to form a seamless nanotube. Right? Cylinder shape, seamless. And all these are called chiral nanotubes. Okay? And 2/3 of the possibility of this are semiconductor as well. So, which means if you will be able to control how the carbon atoms or the graphene sheet fold together to become a nanotube, okay, you will be able to make the materials that you like. You want to make them a conductor, or you want to make them a semiconductor. Okay, so this is nanotechnology. You manipulate atoms, okay, to form what you want. All right. So this is just one of the examples of carbon nanotubes. Okay. All right. What you have is just one piece of the super graphene sheet, right? So what you form is the so-called single wall nanotubes. Okay. But now you can have 2 layers of them, 2 layers of the cylinder in a coaxial manner. We call this double wall carbon nanotubes. Or if you have more than that, okay, this is the so-called transmission electron microscopy images, which means you are looking it from the side. Okay, you can see many layers. Some of them 2 layers and multi-layers, and some of those more than 2 layers we call it multi-wall carbon nanotubes. Okay, is it clear to you now? Any questions? So sounds like we will be producing a batch of physics student graduate here become expert in nanotech. At least in carbon nanotubes. Yes. Okay, I don't go through the mathematics here because of short of time. It depends on the folding angle that you have. Okay, you will have to define with the vector what we call A1 and A2 vector. Okay, if I want to go through this a little bit. So for example here, you define A1, A2 vector, right? And by manipulate how many A1 and A2 you have, you are going to fold the tube along the diameter of the tube, which defines your chiral angle. By knowing the chiral angle and the angle of your chirality, you can calculate whether this is semiconducting or magnetic. Alright? We can go through the details next time. Okay, before this, I have to quickly go through some of the promises. Sky elevator. Wow, looks great. So, you're going to build an elevator just like the one outside that connect you from the Earth to the Moon. So if you can do that at University of Malaya, maybe years later, a lot of just married couple, they just come to University of Malaya in common physics. Why? You want to ride the elevator to the moon for the honeymoon. But what is the distance between the moon and the Earth? Physics students know what does this mean, right? And can you grow nanotubes this long? What is the world record of nanotubes length so far? Close to 1 centimeter. So this is your assignment as a physicist if you're involved in the research of nanotubes. I give you 10 years time, okay? Come back to University of Malaya, build the elevator. Alright, you can grow the tubes vertically aligned like carpet, alright? So imagine that you have many nanotubes, which is like my fingers, right? You know that this is nano, very small diameter, close atom. So when two very small things come very close together, there is a force called van der Waals force. So they will stick together. So when you stick together, when you try to pull one out, the rest will follow. Okay, like domino. So if you do that and you keep twisting it, you will form a yarn. Ladies know yarn, right? Okay, or the string that you have. And you can make any shape that you want. If you have one string, you can use 2 pieces, 3 pieces, etc. to form a cable that you want. And hopefully this can be very strong. But so far, unfortunately, the strength of some of this cable will be only as strong as the piece of plastic that you are holding. Only at this level. Even those single piece of nanotubes can be as big as diamond. Okay? But now you're having very short tubes. Right? You are joining many of them to build a rope. But if you are having real one piece of nanotubes, it can be as big as diamond. Okay? So if you can make a long cable, you have the chance to reach that area. And now we talk about coaxial nanotubes, right? So for example, if you have more than one layer of nanotubes, this is 1, 2, 3, 4, 5, 6 layers, coaxial. So if you can pull some of the cylinder inside, outside, become outside. For example, if I have one big cylinder like this, right? And then I have another smaller cylinder inside, like this, okay? So I can pull this in and out, okay? So this is a piston, right? If you believe it, you might build an engine with a piston as small as nanometer. There are many more, but I don't have time to go through this. In principle, you just have to put a metallic plate here connected to outer wall of the tube so that this one is free swing. Okay, if you do that by using appropriate electrode configuration, you will be able to rotate the plate here to different degrees in orientation. So this is like motor, right? So if you can build this, then you have a motor in a nanoscale size. Nanoprobes. We know that a nanotube is small if you can attach this to the so-called scanning probe microscope, which is very sharp tips in micrometer. But then on the tips, if you attach a nanometer tubes, right? For example, if you have a surface looks like this, right? Imagine if you are using your fingers. If your finger is so big, do you think the tips here can touch at the corner? By looking at this geometry. Okay. If you are using a pyramid probe like this, can you make the tips touching the corner here? You cannot, because the wall here will stuck at the edges here. But now if you have a finger which is sharp, you can touch all the way down the bottom. Right? So in this case, you will thought the surface is look like this, but it's actually different. But now if you have a tube, you can see the actual surface. Right?